Today we'll be doing the integral from 0 to 1 of 1 divided by 1 plus x cubed dx. And to start off, we will factor x cubed plus 1. So x cubed plus 1 can be factored into x plus 1 times x squared minus x plus 1. So replacing this into the integrand, we have the integral from 0 to 1 of 1 divided by x plus 1 times x squared minus x plus 1 dx. And from here, we'll use partial fractions. So we're going to have a over x plus 1 plus bx plus c divided by x squared minus x plus 1 equals 1 over x plus 1 times x squared minus x plus 1. But this means that a times x squared minus x plus 1 plus x plus 1 times bx plus c is equal to 1. And from here, we'll plug in some certain values. So if x equals -1, we're going to have a times -1 squared minus -1 plus 1. And then this will be 0, so this is equal to 1. But this means that we're going to have a times -1 squared is 1. Negative times -1 is +1, and plus another 1 is equal to 1. So 3a is equal to 1, so a equals 1/3. And if x equals 0, we're going to have a plus c is equal to 1. This means that c equals 1 minus a. Okay, we write 1 as 3 over 3, and we said a is 1/3, so minus 1/3. So we get c is equal to 2/3. And now we could plug in x equals 1. So when x equals 1, we're going to have a plus 2 times b plus c is equal to 1. And we have to solve for b. So we have a plus 2b plus 2c is equal to 1. And plugging in the values, we said a is 1/3. So 1/3 plus 2b plus 2 times c is 1. So we have 1/3 plus 4/3 plus 2b is equal to 1. So we have 2b plus 5/3 is equal to 1. So 2b equals 3 over 3 minus 5/3, which is -2/3 multiplying by 1/2. You see that b is -1/3. So we said that a is 1/3, b is -1/3, and c is equal to 2/3. And we have so far the integral from 0 to 1 of 1 divided by x plus 1 times x squared minus x plus 1 is the integral from 0 to 1 of a over x plus 1 plus bx plus c divided by x squared minus x plus 1. So now all that's left is to plug in these constants. So we have the integral from 0 to 1 of 1/3 times 1 over x plus 1. We have plus -1/3 x plus 2/3 divided by x squared minus x plus 1 dx. We could factor out a 1/3 in the second integral. So we have the integral from 0 to 1 of 1/3 times 1 over x plus 1. And then we're going to have a plus 1/3. And we have a -x plus 2 divided by x squared minus x plus 1 dx. And now from here, we could separate the integrals. So we have 1/3, the integral from 0 to 1, 1 over x plus 1, plus 1/3, the integral from 0 to 1 of, now we're going to have 2 minus x divided by x squared minus x plus 1 dx. And this first integral is quite straightforward. We're just going to have a 1/3 natural log of x plus 1 from 0 to 1 plus 1/3 integral from 0 to 1, 2 minus x divided by x squared minus x plus 1. And we're going to have a 1/3 the natural log of 2 plus 1/3 integral from 0 to 1, 2 minus x divided by x squared minus x plus 1 dx. And now from here we have to complete the squared on this denominator. So x squared minus x, we have a -1 here, and it's going to be a -1/2 squared, which is a 1/4, so plus 1/4 on both sides. So we have a x minus a half quantity squared equals -3/4. This means that x squared minus x plus 1 factors into x minus a half quantity squared plus 3/4. So now let's replace this into the integrand. So we have 1/3 the natural log of 2 plus 1/3, and then the integral from 0 to 1 of 2 minus x divided by x minus a half quantity squared plus, I'll rewrite 3/4 as the square root of 3 over 2 quantity squared dx. And now from here, from the second integral, we can use a trig substitution. So we're going to let x minus a half equal square root of 3 over 2 tangent theta, but that means that x is the square root of 3 over 2 tangent theta plus a half, and dx is the square root of 3 over 2 secant squared theta d theta. And for the bounds, solving for theta, we're going to have a 2 over the square root of 3 times x minus a half is the tangent of theta, but that means that theta is the arctangent of 2 over the square root of 3 times x minus a half. And now for the bounds of integration, so theta 1 will be plugging in x equals 0. We're going to have the arctangent of 2 over the square root of 3 times -1/2, but the 2's cancel, so we're just left over with the arctangent of -1 divided by the square root of 3, but that sorts out to -pi/6, and theta 2, plugging in 1, have the arctangent of 2 over the square root of 3, and 1 minus a half is a half. So these are gone, so we have the arctangent of 1 divided by the square root of 3, that'll be pi/6. So our new bounds of integration are from -pi/6 to pi/6. And so now using this information, we're going to have 1/3 the integral from -pi/6 to pi/6 of 2 minus x, the square root of 3, tangent theta plus a half, divided by the square root of 3 over 2 tangent theta squared plus the square root of 3 over 2 squared, and dx is the square root of 3 over 2 secant squared theta d theta. And I'll focus on the denominator. So we're going to have a 3/4 tangent squared plus 3/4, but that's 3/4 tangent squared plus 1, which simplifies into 3/4 secant squared theta d theta. So now we have 1/3 the integral from -pi/6 to pi/6 of 2 minus the square root of 3 over 2 tangent theta, then minus a half divided by the denominator, which is 3/4 secant squared theta. Ignore the d theta and times the square root of 3 over 2 secant squared theta d theta. So as you can see, the secant squares cancel, and we could put the constants in the front. So we're going to have a 1/3 times 4/3 times the square root of 3 over 2, and then the integral from minus pi over 6 to pi over 6. 2 minus a half is 3/2. So we have 3/2 minus the square root of 3 over 2 tangent theta, all of this d theta. And we're going to have a, well, 4 is 2 times 2. So these two are gone. So we're left with 2 times the square root of 3 over 9. And then the integral from minus pi over 6 to pi over 6 of 3/2 minus the square root of 3 over 2 tangent theta d theta. And now we just integrate this. So we have 2 times the square root of 3 over 9. Then 3/2 theta minus the square root of 3 over 2. And we have the natural log of secant theta. This is evaluated from minus pi over 6 to pi over 6. So evaluating at the endpoints, we have 2 times the square root of 3 over 9, and 3/2 times pi over 6 minus the square root of 3 over 2, the natural log of secant of pi over 6. That would be 2 over the square root of 3 minus 3/2 times negative pi over 6 minus the square root of 3 over 2, the natural log of the secant of negative pi over 6. That would be the same thing as 2 divided by the square root of 3. So now simplifying some things, we have 2 times the square root of 3 over 9. We're going to have a 3 pi over 12 minus the square root of 3 over 2, the natural log of 2 divided by the square root of 3. And we're going to have a plus 3 pi over 12. And then we're going to have a plus the square root of 3 over 2, the natural log of 2 divided by the square root of 3. And as you can see, we have some nice cancellation here. We have a 3 pi over 12 plus 3 pi over 12, but that's 2 times square root of 3 over 9. That would be 2 times 3 pi over 12, but that's 2 times 6. So these are gone now. And we can multiply the 2 and 3 here. So we have a 6 times the square root of 3 times pi divided by 9 times 6, but the 6 cancel. So for that secondary integral, we have pi times the square root of 3 over 9. So now we have that the integral from 0 to 1 divided by 1 plus x cubed dx is that 1/3 natural log of 2 from the previous first integral plus pi times the square root of 3 over 9 from that secondary integral. And so that is the final result. Thank you very much for watching.